I know we just got done working in technically what was called Chapter 6 of the old book. Well, this is Chapter 6 of the new book. It's convenient. This does not take very long to get through. Quite honestly, I think we'll be able to fly through 4 sections of it this week alone. I actually anticipate throwing a quick quiz at you on this coming Friday, a little short one to go with that, over the first 4. Really, really fast. Then, let's see, the next week, we'll definitely be done with this chapter before break, because I think this chapter has 7 sections, I want to say. The latter half of the chapter, spend a little bit more time on it, because we got a little bit of graphing in there. I think next week, we have one day that I know I'll be gone for math team, and then there's a half day. So we've got that a little bit shorter time next week, and then we have the 2 days before break. Because, we have enough breaks. So anyway, what we're doing today is working with what are called nth roots. Basically, this is what we do. You have a to the n equals b, where the new book kind of what we call oversimplifies a lot of the material for you. This is basically this. That's what that means. That's not a point that just did that dot for some reason. That's what that is. You can work back and forth with these. If 2 cubed is 8, that means that the cube root of 8 is 2. So what you wind up with to undo these, a would equal the nth root of b. It's called an nth root. Okay? We've done a couple of these things in class before where we've had to take square roots. I showed you guys the short way of simplifying radicals with the calculators using tables. Remember how we were searching through, you take your number divided by x squared. If you want to find a cube root, you take it divided by x cubed, 4th root, and so on. It is, bless you, very simple. So basically this works out to be 2 cubed is 8, therefore the cube root of 8 is 2. When you take an odd nth root, it's just whatever the sign is. If it's an even nth root, it's going to be plus minus. It's pretty easy to remember. Just think in terms of square roots. Okay? Because if you take a square root of 16, it could be plus or minus 4. If I take the square root of, or cube root of 8, it's only going to be 3. 2. Because 2 times 2 is 8. Or if I want to take the cube root of negative 8, is there going to be an imaginary there? Remember what this means. Cube root of negative 8 means what are 3 numbers that are exactly the same that you multiply together to get negative 8? Well, that's negative 2 times negative 2 times negative 2. So you can take an odd root of a negative. Odd roots of negatives are fine. Even roots of negatives give you unreal answers. It's going to give you your imaginaries. Quite honestly, you don't really deal with imaginary, like with 4th roots or anything like that. Okay? So you don't have to really worry so much. Me?
How do you get to the book from your Chromebook?
What's that?
How do you get to the book?
You should just say, hit algebra 2, click it. And then, remember it's the 15 clicks to awesomeness?
Oh yeah, I told you, well, we have
15 clicks to awesomeness. Basically, this is what I just said. If even, you get plus minus. If it's odd, it's whatever the sign is, and from there. If it's, excuse me, any nth root of 0 is always going to be 0. Oh no, what's the square root of 36? Or, oh no, what's the square root of a 4th? Oh no, what is the opposite of the cube root of 64? Oh no, what is the cube root of negative 27? Boy, that was tough. I got really worried that you guys weren't going to know what to do there. Boy. You're waiting for the other shoe to drop, aren't you? Stuff is pretty silly. I wouldn't worry so much about this. You have nth roots of nth powers. There is a really awesome shortcut way that I'll show you guys how to simplify out this stuff. It works every time and it makes total sense. More often than not, I'm always going to put a little what's called a caveat into directions that you can always assume that all of your variables are positive. That way you don't have to worry about this whole absolute value thing. What happens here is sometimes is that if don't write this out here. If you take an nth root of and your n value winds up being even, they want to throw absolute value in there so that way it keeps the variables positive, because you don't know whether it's going to be a positive or negative variable. It's not something you really need to worry so much about in Algebra 2, and quite honestly, we don't worry about it a lot in pre-calc either, because we always say that variables are positive. We always assume variables are positive. This is the one time we'll be able to do some angle side-sides. It's all right. You can angle side-side this. It's not a problem. So I wouldn't worry about this. Basically, it's going to allow us to do this. Cube root of, let's see. Oh, I expect to do 4. It's going to allow us to simplify something like that. But what I want you to remember is some of your basic exponent rules. Remember a couple of chapters ago we talked about exponent rules, like same base, different exponents. If you're multiplying, you just add the exponents together. Where we did something where it was x to the third times x to the fourth equals what? X to the seventh. So basically what you're able to do here when you're simplifying radicals like this is you're taking out pairs. 4 goes into 5 how many times? Once. How many are left over? 1 comes out, 1 stays in. 4 goes into 4 how many times? 1 comes out, there's nothing left to stay in. 4 goes into 12 how many times? Actually, we need to change this to a 14. 4 goes into 14 how many times? 3. So 3 come out. How many stay in? That's how this works. You're taking out groups. You'll take out groups of them because you can rewrite your exponent rules as this whole thing here could be rewritten as x to the fourth times x to the first, y to the fourth, z to the 12th, and z squared. You're taking out groups of that nth power. It basically negates itself. The square root of junk squared is always junk. That's where this comes from. That's why that works. Because you can work with your exponents that way. Your nth roots with the nth to the nth degree. It always works out that way. It's a nice shortcut. Okay. Does that make sense? What I was doing there? I was just quickly dividing and leaving remainders inside, bringing out the holes. That's it. Oh, speaking of division, did I tell you guys the reason why we do the long division? Slant asymptotes. When we get back from break, we'll probably have just enough time to start a couple of sections of the next chapter, which deals with that. Going to be reworking a little bit of what we're going to finish out for the semester, how far we're going to be able to get. Because if you think about it, we get back from break, there's only, 5 days and final start. It's kind of hard to really get too far involved without being able to do a little bit of review. So, who knows what we'll finish out. I should have a better idea of that before we get to break, so I'll give you guys, whether it's some study stuff or whatever. We'll go from there. Okay. Simplifying radicals then. What do you think, I didn't show you this yet. What do you think the number is of the nth root of a square root? 2. Okay. The number that's out here for an nth root is technically a 2. They just don't write it. Okay. So when you start to think about simplifying the way I just did, well, what's the square root of 16? 4. 2 goes into 8 how many times? Is there any left over? You're done. Now, I'm not really worried about plus minus here because it's just a simplified problem. We'll do plus minus stuff if you're solving equations, just like we did before. Okay. Same deal here. 4 goes into 8 how many times? So how many come out? 2 come out? Any stay in? No. 4 goes into 12 how many times? How many come out? How many stay in? So you get x squared y cubed. There's another reason why this works. Remember when we did, can I go to a clean one real fast? I'll come back to that one here in a second. Remember when we did this? We did 2 squared was 4, and then we said 2 to the first was 2, and then 2 to the 0 was 1, and then we said 2 to the negative 1 was 1/2, and so on and so on. Well, what's happening here is that when you have this nth root, a square root of n, when there's no value out in front, that means it's n to the 1/2. A square root is a half power. A square root is a half power. A cube root would be a third power. A fourth root would be a fourth power, and so on. Okay? So what happens here is that if you had this square root of, what was it, x to the 8th, y to the 12th, that could be rewritten as this. X to the 8th, y to the 12th, all to the 1/2 power. And whenever you had power, what'd you do to the exponents? You multiply. What's half of 8? What's half of 12? 6. That's why that works. I don't think it was 12 in the other one, was it? Oh, but it was what the fourth root, so that's why. That's why that works, because you can use fractional exponents as nth roots. Okay. I know this book brings that in a little bit later on. Our old book hit you in the first section with all of this information, so I figured just show you a little bit of it as we go along. It might make the latter half of this really, really fast. Okay. I'm not losing anybody yet. Not too early. Well, probably always too early, but whatever. Do we need to do these 2 examples? Are you sure? I'll work with you. I'm worried about you because you rarely acknowledge anything. So the fact that you shook your head means that you're not dead.
I'm good.
All right. Whew. Okay. I'm not going to make you do these. These are stupid. Questions? Let's see if we can figure out this math Excel mumbo jumbo. Now, if I'm not mistaken, we should be able to get. Click off one of these. Yes, ma'am. Mine's charging. I don't think I have a spare one. Let's see if we can make this work then. Yeah. So, with any luck, if you guys remember, we have to get to the Pearson stuff. So we have to click where it says Pearson. We have to click Pearson again. 3. Your Illini cloud should pop up. And click that one. And click again. We're at 6 now. Now, I believe yours just shows up as just one class, right? And I think it's this one. I think your guys are this one. So now I should be able to click Math Excel, right? and there should be homework. Right? Did that show up for you guys?
Not there yet.
Not there yet. I know there's a lot of clicks. A lot of clicks. Is it working on the phone too? If you want to unplug mine and use it, go ahead, because I think mine might be charged. Yeah, that's what it looks like. Now click on it.
No, we already did it.
I just talked to her. Well, this is a Chromebook charger, but I was just talking to you and I just. I don't know. I haven't used this program yet. Yes, sir.
I already did it.
I had to redo it because I don't know if it worked or not.
It says I have 100% because I did that.
Congratulations!
It said I did it on that day.
All right. Well, cool. You guys made it work. So,
I thought it was homework, so then
that's fine. I wasn't sure. I mean, like I said, I was anticipating to be here, but then I figured since what happened, I just let it go and I didn't turn it off, so I wasn't worried about it. So, if it worked okay and it wasn't terrible, is anybody not getting in the system to make this work?
What if we did really bad on it because I had all these absolute values that I didn't know how to do? Well, I only missed the
But
point.
that's fine. I wouldn't worry about it because when we get to like quizzes and things like that, I'm always gonna say assume all variables positive. Okay, and go from there. Now, the other thing I want to remind you guys was that how do you get the actual book?
you had to do 11 clicks.
You had to do 11 clicks. Yes, you got to get a couple other clicks there to get to the book. That way you can see that as well. But at least once this loads up, I hate this book. I'm sorry. I love this book. The accessibility is great. 15. Because that's how many it takes to get to this book. Class website. Pearson. Open tab. And then we're in radical function and rational expressions. And there we go. And it kind of rolls you through all of it. Okay. Questions? Like I said, we're going to be able to roll. I think what this textbook has done is that these first 3 or so sections used to be done in about 2 in the older book. So I'm going to kind of melt between the 2 here to try to make this stuff work, just so you guys get the idea and not go off too fast with all of it. I will suggest, though, I'm trying to think, what was the other section we got here? Multiplying and dividing, that's really easy. I should have done 2 of these today. Yes, sir.
Yeah, is this the right answer?
I don't know, I haven't done prompts yet. I don't even know what I don't know.
It shows it on the screen, but
Seriously?
Yeah, but I think it probably wants you to put the absolute value on that.
it does.
That's why. It's because they're not saying the whenever you have the where it's not an nth root, where it's not or where it's an even root, you have to throw the value on it. No, just never mind. Correct. Because it's here. Bring your calculator. You're the best. Well, I shouldn't say that. Then you telling other people they're not. Tell them to hurry up. Is it working?
Where do you put the
I don't know. I tried it on the phone. It goes around the leg. Yeah, you have to do an absolute value where you take it. Because B wound up being an odd exponent. Correct?
USC.
I put it in.
Washington lost to USC. Alabama
That's
50
correct.
East. USC.
I put it on both of them.
USC. Washington.
See, if you just put it around A.
Doesn't matter. We're the same. Ranked quarterback. Doesn't matter. It's still 50
I am going to test what they said.
Oh, you know why? Because it's forcing you to make, because since A to the third, when you cube something, it could be negative.
How could it be that?
But when you square something, it'll always be positive. So you throw your absolute value around stuff that winds up with an odd exponent, that way it always keeps them positive.
But why is
That's-
it 8 in the 9th?
Oh,
Say it.
I don't know.
I can't see.
I don't know if
I can't see.
This is what I'm gonna sign for you.
Professional, the best player on all the college team.
I think that
No.
Alabama might not win, but they could keep up. They would get the Oh, really? Is that why?
I think you might have, two goes into 18.
All I hear out of your mouth right now.
Yeah, just think of it that way. Two goes into 18 how many times? What's happening here is this, guys. If you get something like this, where it's A, 18, B, what was it, 16? This is a 2 that you don't see. 2 goes into 18 how many times? 9. If it's going to be 9 times, it's A to the 9th. That means this has to be an absolute value because what forces it, because if you take the square root of something, it has to stay positive. Does that make sense? That's what it's doing. B to the 8th, that will always be positive because 8 is an even exponent, so you'll always want a positive value. What they do is they're throwing the absolute value around the values that have an odd exponent. Remember, when we get to the tests and quizzes, I'm going to put that piece in there, like I said, assume all variables will be positive, so you don't have to worry about the absolute value. It's not, don't get upset. Don't drive angry.